Welcome to springlib.
So let's just say we have a bow here. You have a small arrow. Okay. At this, let's just say that this right here is actually max displacement. And that's when you're shooting the arrow. And so essentially this max displacement actually signifies a maximum force. And so when we're saying would it be an underestimate or an overestimate, it'll be an overestimate. So it will be an overestimate we can say to calculate work when we can say when bow is fully stretched, because this is a point of maximum force. When the bow, we can say when the bow straightens out, this force on the arrow will decrease until it will decrease all the way until it releases the actual arrow. And so at the normal position, which we can just draw a dashed line here, at that normal position, there's not going to be any force on the arrow, and the arrow would. Now, what do we mean by force? Well, work is actually the integral of 0 to d of the force dx. And so essentially what this means is that we're integrating over the entire displacement of the force function. And it would actually be better to say force in terms of x times dx. Again, if a force is a function, we are going to that, because if we use simply the maximum force, it'll definitely be an overestimate rather. And so by taking the integral of the work, we can accurate value for the work being done. It's a bit hard because we would have to use, of course, Newton's second law and Hooke's law and the potential energy of a spring, but we could figure out how much work is being done much more than simply taking some force and saying, okay, equals force times. It's a bit more complicated because, again, this is at a maximum displacement. Bow straightens out, arrow will decrease further and further and further. And so using the maximum force will, of course, result in an overestimate of the work being done. That is the end of the solution. Thank you for